All right, so section 1.8 is going to go through a lot of inequality stuff. Back in Math 1150, Intermediate Algebra, before you took this course, we would have covered this stuff in about 3 sections. Today we're covering it in 1. So, like I said, it's going to go a little bit on the fast side for some of this. I'm going to try and go faster in parts and slower in other ones to help you out. This one's just kind of a nice basic one to get started. And the reason I chose this one is because in solving this one, that is getting the x by itself, we end up with something that happens frequently, and that is you're going to have a negative variable on one side of the inequality. Now there's something special that you have to pay attention to when you try and finish solving. To get x by itself, what do we need to do here? Yeah, thank you. Divide by -1. Divide by -1. What special thing happens when you divide or multiply an inequality by a negative?
It flips the sign.
Yeah, sign flips around, so x is less than or equal to -1. Now, a lot of times you're going to be asked to enter your answer in terms of interval notation. So for me, I like the visual part of the graph that helps me out in terms of thinking about interval notation. So if I was to graph this, am I going to put a solid dot or a hollow dot on 1? Solid, thank you. So solid dot, arrow to the left. Now your interval notation is always left-hand endpoint to right-hand endpoint. So at the left-hand end of this, essentially we have to go all the way out to -infinity. And then the right-hand endpoint is a 1. Bracket or parenthesis on the 1? Bracket, good. So that's going to be your interval notation. So you got your inequality, your interval notation, and your graph. I'm not going to ask for all 3 on any particular problem, typically speaking, but you should be able to go back and forth between all 3 different types of notation. This is probably what you're going to have to put in on WebAssign. Let's move down to this next one. This next one contains what I sometimes jokingly call as the F word, fractions. All right, most of you don't really like fractions. So let's do ourselves a favor and get rid of the fractions. Now, what could I do to get rid of the fractions? Well, they've got a few denominators here. The trick is multiply by the lowest common denominator. What is the LCD in this case? There's just only one, right? It's just 5. So multiply this by 5 and this by 5. When you do that, I think the biggest mistake I ever see on this is that people forget to distribute it to both terms. So for instance, for the first part we get 5 times 2/5 x. And the people, it's easy to forget that the 5 has to multiply the 1 because you're like, oh, well, I don't need to cancel any fractions there. But it still needs to distribute itself there. So a 5 is less than 2/5 times 5. I should be the minus there, minus 10x. So, okay, that's looking a little bit better. Now, maybe in working with the fractions, it would help you to do this. Maybe we should write it as being over 1, like this. Now, why would I do that? Well, because I want to encourage you to cancel. And cancel the 5 here. What's that going to leave me with in terms of an inequality? What's left on the left, the left-hand side here? Yeah, thank you. 2x plus 5 is less than 2 minus 10x. Now you saw up above that here when we dealt with the negative in terms of our inequality, you had to reverse the sign on both sides. You can avoid that, and it's probably a good thing to do to avoid negative numbers where possible. We can avoid that by moving the variable to the side with the larger coefficient. Since 2 is bigger than -10, we're going to move the x's to the left-hand side by adding 10x to both sides. And then at the same time, I want to move the constants to the right-hand side. I want to get rid of this. So I'll subtract 5 from both sides. And let's see what that gives me. That gives me 12x is less than negative 3. Okay, not so bad. To finish solving, we would divide both sides by 12. And I'm not sure I'd mark it wrong, but you might get a frowny face if you didn't simplify this. Negative 3/12 simplifies to negative 1/4. Yes?
You have to flip the sign for that one.
Great question. We divided by a positive 12, so that's why we didn't have to flip the sign on that one. But it's a great question. Anything else on example B here? Okay with that one? Let's move on.
I have a
Yeah,
question.
yeah. Go ahead, sir.
So for interval notation, for example B,
Yeah, good question.
it would be, so x is less than, so it would be a open circle, to the left. So it would be, parentheses, negative infinity,
Mm-hmm.
and then comma, 1/4 parenthesis.
Yes. So negative infinity to negative 1/4, and negative infinity and positive infinity are always going to get a parenthesis. Negative 1/4 here gets a parenthesis because we're not including that. So
Okay.
yes, well done. Example C is an example of a double inequality. Now I do want to notice for you that there's a little difference between the left hand and the right hand inequalities here, right? The first one is a less than or equal to, the second one's a less than. Sometimes when people work through these problems, they both change to being the same, both less thans or both less than or equal to. If it starts out like this, it's going to end up like this. Don't make any changes. Now help me out here. If I want to get the x by itself, what's a good place to start maybe? You can divide by 5, but that would give me fractions right away.
You can add 13.
Yeah, yeah. So add 13 to all three parts of the inequality. So that gives me 25 is less than or equal to 5x is less than 45. All right, 25 less than. What next? Divide by 5. Wonderful, thank you. So divide by 5. 5 is less than or equal to x is less than 9. So as far as the graph is concerned, let's see, Jaden, am I going to use a solid dot or a hollow dot on the 5?
Solid dot.
Solid dot. What about the 9?
Hollow dot.
Hollow dot.
Wait, why is it a negative 5?
It's not a negative 5. Oh, sorry. Yeah. My bad. And then I want to draw an arrow between these two. Try and write down the interval notation as well. Chloe, what's the interval notation going to look like for this, please? Perfect. Perfect. All right, so I went through this a little bit on the fast side so I could spend more time with problems like example D and some of the other ones that follow this. This is what's called a polynomial inequality. And we're not going to be able to necessarily solve as nice and neatly as we did for examples A through C when you have a polynomial inequality. So what I'm going to do to start with is I'm going to move the 1 to the other side and get 6x squared plus x minus 1 is greater than 0. Typically in working with these things, I want to get 0 on one side. Doesn't matter which side, but just 0 on one side. And we're going to look at the graph here. If you wanted to follow along with some of this or get some more practice, I've got a little QR code there that you can jump on. But I'm going to take a look at the graph on Desmos. We'll go over it with the graphing calculator soon enough. But let's take a look at this and notice that it crosses the x-axis at two places, here and here. In fact, you can kind of see those places if you were to factor this. This is one of those ones that doesn't factor very easily, typically, because you've got something here. You can't just look for two numbers that multiply to -1 and add to 1. But we do have a little bit of an advantage here. Because there's not much choice in multiplying things to get a -1, the last terms have to be a +1 and a -1. There's no choice on that. And so now we know that the first two terms are going to have to multiply to 6x squared. So what kind of numbers can multiply to 6? Can you give me an example? 2 and 3. All right, 6 and 1, 2 and 3. But it's pretty easy just to try and guess, well, which one's going to work. Either put a 2 and a 3 or a 3 and a 2. Try and figure out which one works. 3 and 2. So if you're thinking, 3x and 2x, how could you check yourself? How could you be really sure that, yeah, we actually got it? Yeah, you could FOIL it all out. So that's going to be your 6x squared. Outside gives you a plus 3x. Inside gives you a minus 2x. Last gives you a minus 1. And these two combine to give me the x that I started with. So that one, because of the minus 1 here, a little bit easier to factor. Typically speaking, you're going to want to know where this is equal to 0. So where does that equal 0? Well, it's equal 0 when one of these factors is 0. So either 3x minus 1 equals 0 or 2x plus 1 equals 0. And these are just linear equations. Move the 1 to the other side, divide by 3, we get x is 1/3. Move the 1 to the other side, you get -1. Divide by 2, you get x is -1/2. And so I'm going to create a number line based on that. So let's put the -1/2 here and the 1/3 here. Now what we saw when we were working with the linear inequalities is that our answer was always an interval. Your answer is going to be intervals again, but this time we've got several intervals to choose from. This interval, for instance, would be -∞ to -1/2. The middle interval would be -1/2 to 1/3. And the last one would be 1/3 to infinity. Your answer is going to be one or two of these intervals. We don't know which one. We want to choose the interval so that the values of x, when we plug them in there, make this expression positive. And the way we're going to do that is we're going to test some points. Now, spoiler alert, we're going to look at this and figure it out right away without even testing any points. To the left of -5, is this graph positive or negative? To the left of -5, take a look at the y-coordinate. The y-coordinate on the graph here, is it positive or negative? It's positive. In fact, it doesn't matter where you are to the left of this x-coordinate, your y-coordinate is always going to be positive. So any value of x that I put in to the left of -1/2 is going to make this expression positive. In between, what happens to the values of x? Negative. Pardon me, the values of y, I should say. Yeah, but you're right. Negative is the answer I'm looking for. And then to the right of 1/2, it goes back to positive. So positive, negative, positive. Which intervals do I want for my solution? Do I want the positive intervals or the negative intervals? Which ones are going to make sure that this is greater than 0? Yeah, the positive ones. So let's just circle the positive ones, and that's your answer. -∞ to -1/2. Union, 1/3 to infinity. Okay. And we're done with that one. Well, sort of. Let's look at what you're going to do on the graphing calculator when you run into these problems. So the first thing I want you to do is go to the equation editor. So hit the y equals key. Clear out anything that happens to be there. And then let's put in the equation. 6x squared plus x minus 1.
How do you do an X on here?
So x is right next to the alpha key up here.
Oh, okay.
Now there's 4 different things on it. Typically speaking, right now it should be showing up as an X for you. There's different modes that you'll learn in your trig class that will help you out with the t, theta, and n. Okay, now there's another setting that we need to make before we look at the table of values that we get here. So hit the second key, then the window key. It's this last setting down here, well, next to last setting for independent. Take your cursor, put it on ask, and then press enter. So for the rest of your natural life, keep this here at ask and auto for independent and dependent. These other 2 settings aren't going to matter once you have independent set to ask. Does everyone have that setting? Carly, good on that? All right. Sure. So you're going to hit the second key, then the window key. That'll take you to this menu. And then cursor down and set independent to ask. All right. So we've done 2 things, right? We've got the window settings or the table settings all set, and we've got our equation entered. So everyone's with me because I want to make sure that you get this part. All right. So from here, let's go to the table. And now you can plug in and test any particular point that you want. So when you do these problems beyond this one.
Where do you get to the table?
Okay, sure. You hit the second key, then the graph key.
Okay.
Now down at the bottom of my display here, you'll see the key history that I've used. So if you need to catch up, you can look at this like second and graph. That's how we got here.
Thank you.
Sure. Now if you wanted to test something in this interval, somebody give me a value of x that's in this interval. -1. Sure. So let's type in a -1. And I get a 4. Great. So that's positive. How about something that's in our next interval? 0. And something over here? 1. So the information that we're getting that we really want is not that when we plug in a 1 we get a 6 or a 0 we get a -1. What we're getting is positive, negative, positive. We're getting the signs of this function in these intervals. So it matches what we saw when we drew the graph. So you just label the results, your test points, positive, negative, positive. You look here and decide, do I want the positive intervals or the negative interval? In this case, it's the positive intervals. So those 2 are your answers. It might feel like we're doing a lot of work for something that looks pretty obvious with that absolute or with that polynomial inequality there, but the graphs of these things aren't always going to stay as these nice, neat quadratic polynomials. They're going to get more complicated, and that's where you're going to want to be able to do this stuff. So let's take a look at example E, unless there's some follow-up on example D. The first thing I did with example D was I got it 0 on one side. I'm going to want to get 0 on one side again. This time, I have to decide, well, where do I want to put the 0? Personally, I'd put it over here because the 3x squared term is bigger than the 2x squared term. That way, I'll have a positive coefficient of x squared. How could I get rid of this from the right-hand side?
Minus 2x squared.
Yeah, subtract 2x squared. And then I've also got to get rid of the 40. So I'll subtract 40. And let's see what that gives me. Well, I'll have x squared. And, well, these aren't like terms, are they? So it's just minus 3x minus 40 is less than 0. All right. So that's my first goal, is you get 0 on one side. The next thing is to find out where this actually equals 0. And I can do that by factoring. Give yourself a second to see if you can't figure out how that factors. Haley, any success? How does this factor? Some help. Two numbers that multiply to -40 and add to -3.
I got 5 and -8.
All right. So 5 and 8 probably present themselves as one possibility. The larger of these two has to have that sign. So one has to be positive, one has to be negative to get a -40. So thank you. Now, where does that mean that this graph could actually equal 0? Can you look at this and say, well, where does x plus 5 times x minus 8 equal 0? Where is that going to be true?
-5 and +8.
Good. -5 and +8. So those are the two numbers that I want to put on my number line. So let's put them down in order, -5 and +8. Before we go any farther, let's label some intervals. So, Brooks, what will be the intervals for this one, please?
-infinity to -5.
-infinity to -5. Good. Keep going.
-5 to +8.
Mm-hmm.
And +8 to +8.
Nice. So I'm going to want to test some points in each of these intervals and try and decide which intervals I need. So let's go back and change our equation. You could type it in factored, you could type it in as you see it here. Either form of this doesn't matter, your calculator doesn't have feelings, so do whatever you find most convenient. I'm just going to type in x squared minus 3x minus 40. Let's go to our tables now. Hit the second key, then the graph key. And let's delete a few points here. What would be some good test values? -6, sure. So -6, 1, one more. 9, thank you. So those would be our test points. Now on an exam, what I would expect from you is a little t-table, something like this, -6, 1, and 9. And I don't care if you give me the numbers here or just whether they're positive or negative. But let's see what happens when we plug in these points. -6, 1, and 9. What's the important information that I need to get from this graph here? Yeah, negative and positive. Thank you, Eric. So it went positive, negative, positive. So positive, negative, positive. Which interval or intervals are going to solve this inequality? Which sets of values of x make this expression less than 0? Yeah, the middle one. So -5 to 8. So there's your solution. Yeah. Try it again. There's your solution. Beautiful. All right. Thoughts on that one? You okay there? Yes.
When it's between a negative and a positive,
Yeah.
I was taught to always make it 0.
0 is a great test point.
Yeah,
So, you know, you could test x equals 0 right here without even, bothering to put it into your calculator. 0 squared minus 3 times 0, 0. Minus 40 is minus 40. But plugging in 0 just tells me that the middle interval is negative the 1 did that as well. So if you want to test 0, if you want to test 0.1, or whatever is in that interval, it's still going to tell you the same information. Because what's happening is that any point between these two roots is going to test out the same. It's going to test out either positive or negative, and that tells you what you need. So thanks for the question. Let's flip it over to the back side here. So I'm actually going to skip this one in the interest of getting to more difficult examples like G. But let me give you a heads up. A lot of times I put problems like this on an exam and people try and take a shortcut. And I know it looks so tempting. Go ahead, tell me. What do you want to do on this one? Square root on both sides. Yeah, sorry, won't work. Because that would just give you x is less than 7. But there's really 2 solutions in this one. And your final answer should really be these 2 intervals. Negative infinity to negative 7 and positive 7 to infinity. If you just take the square root on both sides, you're only going to get one of them. So you would start out by doing this and then going from there. But the reason I'm asking you to go through this pain of putting things into a graphing calculator and testing these points is because your graphs aren't always going to remain as simple as a parabola. They're going to get more complicated. And to try and answer these things just by looking at the graph is going to become an increasingly difficult pain. So let's just automate it. All right, we're going to do that with our graphing calculators. This one's pretty nice. So when your instructor wrote this problem, his favorite sports teams must be winning, so good on us. But let's take advantage of that. So the x plus 6, x minus 4, x minus 8, we've got 0 on one side, and it's even factored. Can you tell me where this is actually equal to 0? Negative 6, positive 4, and 8. Great. Let's put those on a number line again. There's going to be something a little bit different about our number line this time. Make sure you put these on in order. So now we've got 4 intervals, right? One thing I want to point out is that this is a less than or equal to. So that means we can actually include the endpoints. Now, infinity gets a parenthesis, but negative 6, we can actually include that one because we want to know where this is less than or equal to 0. And then negative 6 to 4, again with brackets on both ends. 4 to 8, and 8 to infinity. Okay, looking good. We need some test points in each of these intervals. So I need points here, 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 and here. These are our test points. What are we going to do on that one? What are some test points? Me?
I did negative 7.
Negative 7.
3.
3.
Yep.
Keep going.
5 and 9.
9. What if somebody else wanted to use negative 9, 0, 6, and 12? Would that work? Sure. The thing that you have to make sure of is that you actually get points in the particular intervals. The biggest mistake I see here is people getting 2 points in the same interval and missing an interval. So that's the only thing that we have to really worry about. Let's go back to the equation editor. Clear out the stuff that was there and type in the expression that's on our left-hand side, x plus 6, x minus 4, and x plus 8. Oh, excuse me, x minus 8. My bad. Minus 8. I'll give you a second to make sure you got that expression in. Where's our next stop now that we get the expression in? Table. Thank you. Let's go to the table and get the table to do our heavy lifting for us.
Wait, I'm sorry. Why don't we have to put in the less than or equal to 0?
What we're doing is we're testing where this expression, or the value of this expression at a particular point. So
Okay.
we'll decide where it satisfies the less than or equal to part after we do our testing.
Right.
So good question. So let's go up here. Now you don't have to choose the same points that Eric chose. You could choose different ones. I would suggest whatever points you have there, you just get rid of it by deleting. So that way you don't confuse yourself. The delete key is at the top. And bam, 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 just delete a few times. When you're plugging in a -7, for instance, use the negative or opposite key on the bottom of the calculator. Don't use the subtraction key. If you do use the subtraction key, your calculator will give you an error. Nice. So what information am I looking for from this table? Helen? Positive and negative, right? So let's write down what we ended up with. Let's test it out as negative, positive, negative, positive. Okay. Which interval or intervals are going to make this inequality true? Decide it for yourself first, and then I'm going to ask you to do one more thing here. But try and decide which interval or intervals you want. Now check your decision with a neighbor. Do you agree? Do you agree with your neighbor as to which interval or intervals work here? Vlad, Jose needs an amigo. Jose, to your right, needs a friend. Check out with a friend.
I haven't written it down yet, but I think I'm looking for
Charlie, you guys agree back there?
Yeah.
What'd you guys get?
Negative infinity and -6 bracket.
All right, good. Anything else?
No.
Okay. Is there anything else? Are we good there?
5. Test point 5.
All right. So this interval with the test point of 5, yeah. Both of these intervals make this expression less than or equal to 0. So we're okay there. Now, if you're unsure about the endpoints, you're like, well, should I include the 6 or not? Or, pardon me, include the -6 or not? You could actually type in the -6 and watch what happens. If I type in -6, I get 0. Now do a little thought experiment. Is 0 less than or equal to 0? Is that true? Yeah. So you can use that point. It does satisfy the inequality. Let's keep going with example H here. Solve the inequality and express the solution in interval notation. This is exactly what you're going to see when you work on WebAssign. There's a big difference between this one and G, though. What is the difference?
It's not factored.
Yeah, it's not factored. All right, so my favorite sports teams were losing that weekend, right? All right, so we got to factor it. What's the first thing you always try when you're factoring? What's the first thing you always look for?
You find a common, what is
Greatest
it?
common
Greatest common denominator, or factor.
factor. Yeah, greatest common factor. Thank you. So, is there a greatest common factor here? X. So I'll factor out the x. It leaves behind x squared minus 36. Let's keep going. What else can I do in terms of factoring? Can I factor that x squared minus 36? Difference of squareds. Adrian, any idea how that one's going to factor? Difference of squares? Nice. X minus 6 and x plus 6. Beautiful. Now, when you try and set this equal to 0, that is x times x minus 6 times x plus 6 equals 0, and figure out, well, where does it actually cross the x-axis? If I looked at the graph, where could it change signs? There's only a couple places where it could change signs. How about this one? Where can this change signs?
-6.
-6, good. Someone else for the second one. And the last one, where could this change signs? 0. So you've got 3 different places again where this can change signs. So let's put that on our number line again. Give ourselves some intervals. Careful to put the numbers in increasing order from left to right. I always recommend that you write down these intervals right here, right now, because when you start adding in your test points, it gets a little confusing, and then you get confused as to which is your interval and which is your test point. So let's just get these down now. Jack, what are the intervals there, please?
The negative, or, negative infinity, -6,
Uh-huh.
-6, 0,
Good.
and 0, or, and then 0 to 6,
Nice.
and then 6 to 3.
Perfect. Perfect. So, again, we're using brackets because this is a... Oh, you know what? My bad. I should be using parentheses, shouldn't I? This is a greater than. Shame on me. That is worth a point, though, on your exams. If you're using brackets and parentheses correctly, maybe even 2 points. So, yeah. All these need to be parentheses. My bad. Let's plug in one of these 2 forms of an expression. Either you can plug in x cubed minus 36x, or you can plug it in factored. It doesn't matter. But either way, you have to change what you have in the equation editor. Let's clear that out. I'm just going to plug in the x cubed minus 36x. So here's your x raised to the 3rd power. Press the right arrow to get out of the exponent. Then 36x. Oops, I should probably put a minus sign in between there. The cool thing is that if you make a mistake like this, you can hit the 2nd key and then insert. So there you go. Once you've got your expression there, let's go to the table and plug in some new test points. Second table. Start by deleting all the ones that are there. I need some new test points here. Let's see. Ryan, what would be some good test points for us for this one, please?
For the first one, -7,
Sure. -7.
and then -5,
Thank you. Keep going.
then 2,
Mm-hmm.
and 7.
Perfect. Let's test those and see what we think. So let's see. That's going to be -7, -5, 2, and 7. Now, a lot of times you'll see a pattern that we're seeing in this one. Has anyone picked up on the pattern in terms of positives and negatives? A lot of times they alternate. It doesn't always, but it usually does. So if you see that, that might be reassuring. If you see something other than that, double check your points to make sure you're testing points in each interval and that you don't accidentally have 2 points in one interval. So negative, positive, negative, positive. Charlie, which one do I want? Do I want the negative intervals or the positive intervals?
It has to be greater than 0, so you go positive.
Yep. Want the positive intervals there, and that's your solution. Nice. Nice. Now, like I said, if you're trying to do this just by looking at the graphs, it gets increasingly difficult when you go from your quadratic inequalities to cubic inequalities, and we're going to build on that even further and work with rational inequalities. Before I get there, are we okay with example H? Doing good?
Yes. I just wanted, so if you were writing them both, it would just be like a comma between them, right?
Yeah, so what you'll have to put into WebAssign is going to look like this. Negative 6 to 0 and 6 comma infinity. I don't think they're going to have a union sign. They're going to have a comma. They're just going to ask you to list it with a comma between these two. So, Jack, is that right?
They have both.
Oh, they have both? You can do either one? Okay, thank you. All right. I like seeing this on a test. If you put a comma between them two, that's okay. All right? But I like the union there. Let's move on down to example I. The good news of example I is that we've already got 0 on one side. So, yay. Looking good there. But then what? How do we get these points? Well, we're going to have to do two things. We're going to have to set the numerator equal 0. That's going to be x minus 5 equals 0. So where's that true? X equal 5. And then we're going to have to set the denominator equal 0. So let's do that. The denominator equals 0. So it's going to be x plus 2 equals 0. And that's going to be true when x equals negative 2. So we have those two possibilities where this function can change signs. Everywhere in between those points, it's always going to be either positive or negative. We just got to figure out which. So let's put those two numbers on the number line and then list up our intervals like we did just a moment ago. So let's see, we'll put them in order, negative 2 and 5. But we're going to have to be particularly careful about putting in brackets or parentheses. So, in particular, which one of these points cannot be part of my solution? Negative 2. Excellent. Why? Why can't negative 2 be part of my solution? Yeah, you'd have a 0 in the denominator. You can't divide by 0. It's a mathematical no-no. Don't pass go. Don't collect $200. You're just out of luck. So when I list my interval, even though this is a greater than or equal to, I'm just going to write negative infinity to negative 2 with a parenthesis. I can't use that negative 2. Nor can I use it here. So negative 2 to 5. But can I have 5 as part of my solution?
Yes.
It's okay to divide into 0. It's just not okay to divide by 0. So 5 is going to get a bracket here again, like that. So not a bad idea to try and be careful with these things up front. Now, in a problem like this, there's probably 2 points dedicated to brackets or parentheses at the end of your problem. So don't miss out on those 2 relatively easy points. Now, as far as putting this into your calculator, let's do that. There's a couple different ways that I'll suggest to put those in. First of all, I'm going to clear out this table here of my old values. Then I'm going to go back and change my function. Now here's a couple different ways to put this in. And I'm going to teach you something new and cool about your graphing calculator, at least some of you that haven't had me before. Here's the way that will work for all of you though. Left parenthesis, x minus 5. Divided by parenthesis, left parenthesis again, x plus 2, and then a right parenthesis there. So looking good there. Now, if you've got an up-to-date TI 80-something, and you're like, yeah, I know I'm going to screw up these parentheses, here's a way that you can kind of avoid the parentheses. So if you hit the alpha key, then the y equals key, the first option there allows you to do a fraction kind of like the way I would write it on the board. And if we do it this way, now I just type in x minus 5, x plus 2, And now it'll just give me a nice fraction right here. Let's go look at some test points. I am going to have to come back to this because there's a little thing that we're going to tweak. But at least you'll see the difference here. So I need some test points here. Let's see. Sarah, go ahead.
I can give you a test point, but I have a question.
Okay.
Since x plus 2, like on the denominator, it can't equal 0
Right.
for this nonlinear inequality, does that mean that at -2 there's going to be a vertical
Asymptote. Yes. Yeah. So if you looked at the graph, you'd see a vertical asymptote there. Yep.
Okay. And then a test point for -infinity, comma, -2 would be -3.
Okay. Good. Want to finish them out? What would be some more?
Then 0,
Mm-hmm.
and then 7.
Okay. Perfect. Perfect. So let's use those test points, or you can choose other test points if you would like. So -3, 0, and 7. Now, the one annoying thing about using the fraction key is that, well, you didn't get decimal values. It gave you actual fractions. If you're more comfortable with actual decimal values, like, no, I don't want to look at the fractions, we can make that work too. But either way, it's still going to give you what you need. What's the information I need here? Positive, negative, positive. All right, so let's put that down. So it was plus, minus, plus. Do I want the positive intervals or the negative interval? Positive. So that's going to be this one, and we're done. So overall, it's going to be -infinity to -2, union 5 to infinity.
I thought it couldn't be the one on the left, so.
You can't have this endpoint. In fact, I appreciate you asking here. Let's do a little experiment. What's going to happen if you plug in a -2? Try and use -2. Tell me what happens. What do you see on your calculator when you plug in the -2? Error. Your calculator is screaming at you what your instructor is telling you. Like, you can't use the -2. What if you're like, well, wait a minute, what about that 5? Well, if you put in a 5, you get 0. And 0 is less than or equal to 0, so we're good there. So if you need to or want to, test the endpoints. It's going to tell you brackets or parentheses if you have to decide that question. So, very nice.
Will the denominator in a nonlinear inequality, if it's a fraction, always be a vertical asymptote?
Not always, but usually, often it will be.
Okay.
Yeah, but we'll go over graphing these things in chapter 3. Right now, we don't have to worry about it. Now, I'm going to set you up for example J, but hopefully if we get a little time later today, I'll let you do this. Before I do my, numerator and denominator equals 0, I've got to rewrite this so that I have one fraction on the left-hand side. I can't do this with two fractions. I have to have one. Over here, I had 1. Here, I don't. So in order to get these two together, I'm going to need a common denominator. Your common denominator is not x plus 12. Your common denominator is a little different. Can anyone tell me what the LCD for this would be? Nice. X plus 3, x plus 4. So what I'm going to do is multiply the first one by x plus 4 over x plus 4. What does x plus 4 over x plus 4 reduce to? 1. So I'm multiplying by 1, which doesn't change things. And over here, someone hasn't a chance to speak this morning yet. What do I get over here? X plus 3 over x plus 3. All right, x plus 3 over x plus 3. 0. So that gives me x plus 4 over x plus 4 times x plus 3 plus x plus 3 over x plus 4 times x plus 3 But this is what I wanted. I wanted common denominators. So I can add the numerators. Knee. What do I get when I add the numerators, please? X and X, 4 and 3. Yeah, so combine the like terms. What would that give me? And what else? X plus X would be 2X plus 7. So before you start figuring out test points and intervals and all that stuff, you have to get the expression written with one fraction. So this is a little bit of a difference between this and Math 1150. In your Math 1150 class, I didn't give you problems where you had to do this step first. Here, we're in college algebra, you will have to do that step first. So from here, the rest of it's the same. You're going to end up with points at -4, -3, and -3.5. So it's going to mean it's going to be a little bit tricky to try and figure out test points because you have to test points in that interval. But that's what you're going to need. Whew. All right, coming towards the end of this. I know it's a long section. All right. Let's take a look at an absolute value problem here. And I'm going to make it, you know, a friendly one to start with. So let's take a look at y equals, say, the absolute value of x. And I want to know where that's greater than or equal to the line y equals 5. So if I wanted to know where it's greater than or equal to 5, that is, this graph is greater than or equal to 5, it's going to be to the right of 5 and to the left of -5. But if I want to know where, for instance, the absolute value of x is less than or equal to 5, so absolute value of x less than or equal to 5, you don't have to write this down. What I want to point out is that it's going to be an interval, one interval with stuff in between. In fact, it's going to be between -5 and 5. That's where you're going to find values that solve this inequality. So there's a little shortcut that my Math 1150 students might be annoyed that I didn't teach them last semester, but it is what it is. When you're solving this, we can take kind of a shortcut. Instead of just solving where 3x plus 2 is less than 7, and then doing a separate case for something else, I can repeat this by putting it between 7 and -7, and then just solving for the inequality that's in between. Now this is for the less than case. So the price we have to pay for making this easier is that you have to keep this straight from what we're doing with the greater than case, because the greater than case and the less than case are going to be completely different. For the less than case, let's just solve this double inequality now. If it starts out as a double inequality, it's going to remain a double inequality. So let's see. We'll subtract 2 from all three parts of the inequality. How am I going to finish this one up? Carly, some suggestions? Yeah, divide by 3. And so I'll end up with -3 is less than x is less than 5/3. So there's the inequality. Let's take a look at the graph. -3 and 5/3. Brackets or parentheses on that one, Carl? I mean, solid dot or hollow dot?
Hollow dot.
Yeah, hollow dot and everything in between. What would be the interval notation for that one, Ian?
Negative infinity. Negative 35.
Brackets or parentheses? Parentheses, yeah, good. Because we're not including the endpoints. Yay. So nice and easy on the absolute value less than case. Question? Brooks, looking good on that one? Thank you. For the absolute value greater than case, I heard somebody talking this morning. He's like, well, you know, it really helps me if I understand. And I want to help you understand why we're going to do what we're going to do. Let's take a look at the absolute value of 5. Can someone calculate that for me? What do we get? 5. Nice. That's when something in here is positive. If I had a negative, what's the absolute value of negative 5? It's also 5. But what you're doing, even though you may not realize it, to make this a positive 5, you're taking its opposite. You're taking the opposite of what's inside here. And the opposite of that negative 5 gives you your positive 5. Why am I explaining this? What relevance does this have? It has relevance to solving the absolute value greater than case. So this is the greater than case. And what I want to highlight in your mind is that there's a distinction between the less than case and the greater than case. You're going to have to do different things to solve here. So there's two possibilities that we have to consider. The first possibility is that what's in here is greater than 0. If it's greater than 0, I can just remove the absolute value. I don't need to do anything. So I'll say, all right, well, let's solve 3x minus 2 greater than or equal to 5. Great. If it's less than 0, then what did I do to take care of that? I took the opposite of what was inside, right? And we're going to take the opposite of what's inside here again. Now, taking the opposite doesn't mean just changing this sign. It means changing the whole thing. Now I'm going to jump speed this one to the solution. If you add 2, you're going to get a 7 over there. Divide by 3. We're going to end up with x is greater than or equal to 7/3. That's one part of this. But there's another part. And let's see if we can solve that one. So here I'll distribute the negative to both terms. And then I need to solve. So let me keep on going. That's going to be negative 3x is greater than or equal to 3. So x, well, I'll divide by negative 3 and I get a negative 1 there. But what am I being coy about? What's missing?
Flip the sign.
Yeah, you got to flip the sign. So it's going to be x is less than or equal to negative 1. Let's graph this. And I'm going to do this kind of in a color coordinated fashion. So when I graph it, typically speaking, I only draw the numbers that I need. I need a negative 1 and I need a positive 7/3. X is greater than or equal to 7/3. That's going to get a solid dot with an arrow to the right. X is less than or equal to negative 1 is also going to get a solid dot, except this time you're getting an arrow to the left. You get 2 intervals. They face away from each other. That's a nice double check in your work. If you look at something and say, oh, well, wait a minute. My 2 intervals face the same direction. If that happens, you've made a mistake. When you're doing these types of problems, you should get 2 intervals that face away from each other for the greater than case. For the less than case, you're going to get 1 interval in between. But those are the two distinct cases that you're going to see when you work on the absolute value inequalities.
Well, that makes a lot of sense with the graph.
Cool. Yeah, you can actually look back at our graph here and take a look here. When you're dealing with the greater than case, that's going to be to the right of 5 and to the left of negative 5. If you're doing with a less than case, when is my graph less than 5? Well, that's going to be this interval in between. So there's a couple ways to approach this, but make sure that you get those two different intervals. Now let's see if we can't put that together with some work on the back side, the last part of this handout, and I will go back and mention some stuff, for example, M. Well, let's look at the back side of this. And I want you to ask yourself something first. And answer to yourself silently. Is this an absolute value greater than case or an absolute value less than case? Now compare answers with your neighbor. Greater than case or less than case? All right. What's the consensus? Greater than case? All right, so an absolute value greater than case. So this is going to be the absolute value of x is greater than. Now, I'm using solid dots here. So would this be a greater than or equal to? Greater than or equal to. And let's see how far away I'm moving. So I move 1, 2. Oh, I move 2 to the right and 2 to the left. So this is the absolute value of x is greater than or equal to 2. If I had hollow dots here, then I just use absolute value of x is greater than 2. How about the one down below? Absolute value of x less than case. Yeah, absolute value of x is less than or equal to 3. Nice. And guess what? We're done with that one. Now it can get a little bit harder. So give yourself a little bit wider of an absolute value here. Is this the less than, greater than, less than or equal to, or greater than or equal to case?
Less than or equal to.
Less than or equal to. What's in the middle of this? What number is in the middle of that interval? 1. So if you look at a 1, how far to the right to get to the edge of the interval, or in the same way, how far to the left to get to the other edge? What's that distance? 4. So that distance is a 4. I'm going to put a 4 here. What's going to shift this to have a center at 1 is an expression like this, x minus 1. And you might be curious as to why is there a minus 1 and not a plus 1? The minus 1 is going to shift your graph to the right. And you can kind of see that and relate to that by looking back at your polynomials, like y equals x squared. If I wanted to shift that graph to the right by, say, 1, I do y equals x minus 1 squared. Because that minus 1, when you put it in your equation like this, it'll be 0 when x is 1. Which means the point that was here has been shifted to the right by 1. So it's a little counterintuitive, but if you think it through enough, you will convince yourself that x minus 1 is the correct answer there. All right, last word on this section. When you do a problem like M here, and I'm hoping that we get you a chance to do this today, you first have to isolate the absolute value. That's your first goal. You have to get the absolute value by itself before you start doing any plus and minus cases or repeating the inequality. So what do I have to do to get this by itself? All right. Let's subtract 6. I get negative. The absolute value of 2x plus 3 is less than or equal to negative 1. And then I need to do one more thing here. What would that be? Divide by negative 1. Good, thank you. What's the special thing that happens when I divide by -1? Ah, the sign flips. Even though we're not solving the linear inequalities and stuff like that, we still have to be careful about the sign. That's going to be greater than or equal to a 1. This is your greater than case. So you're going to have to set up a positive case and a negative case like we did up here in order to solve. So that I'll leave you to finish a little bit later. And like I said, I hope that we'll get a chance to do that. Whew. All right. Comments or thoughts on this last one? All right. Let's give this one a rest.